A long time ago, I was working on signaling pathways, so all the wires that connect cells and absorb signals and transmit them inside. And I was working on epithelial cells of the gut. And we were thinking, oh, let's put this cytokine and see what happened to the cells. And then, for some reason, neglected to think that the cells live in a sea of microbes. And I was looking at cytokines, these small molecules, and then it occurs to me that I should look at the microbes as a modifier of epithelial cells' function. So that's how it came about. And we had a technology that allows you to study a mouse in germ-free conditions, so without any bugs. It makes a perfect sense. And to look at without bugs, with bugs, what will be the response, and then try to layer down this response with manipulation of microbes. So that was how it works. Yeah, well, we don't know that much about that. So we're still sequencing. We know for sure that there is changes. So some membership decrease in cancer and other members increase. We try to understand what's the function and the consequences of this. So, but there's different signatures. Some are associated with loss of short-chain fatty acid producing bacteria that are the good one. Others are the bad one that will produce different toxin like hydrogen sulfide or genotoxin that hit your DNA and damage your genome, which is not a good thing. So often lead to cancer. So there's groups of bacteria that have function in terms of producing toxic metabolites or genotoxin, and other bacteria that produce protective, and it's all about the balance of these. If you lose the good one and gain the bad one, then the consequences could be cancer. But we don't have a clear understanding of who is doing what. That if you have that, you have cancer. We don't have that knowledge yet. Many things disrupt the microbiome. Most of the microbiome is very resilient. So it's not because you're going to eat sushi a day that your microbiome is going to change. I mean, if you move to Japan and after a year, yes, you may have a change. But it's really resilient until you get an infection. And the infection is often, the change is often associated with the treatment. If you give antibiotics to someone who has salmonella infection, it's not only the salmonella changing, it's the antibiotics that you want to get rid of the salmonella, so it will wipe out a lot of bacteria. Although they are like, oh, it's a gram-negative antibiotics, you will hit a lot of microbes. So that change. But the genome, our genetics makeup also counts for some balance of the microbes. So if you have a specific defect in innate response, you may have a different microbiome than another one. But I don't think we should be too much focusing on the taxonomy of microbes as opposed to their function, because you and me have a very different microbiome, yet we share a lot of function. Very similar function, because they overlap. So even though you have different microbiome, it's not a big deal. When it's in the disease state, that's something else. So infection, medication, some medication have a profound effect of microbes, and a lifestyle that could be at the extreme of the health lifestyle could have consequences on the microbiome. Right, so we don't know the plasticity of how much the changes will be causing disease. There may be some plasticity that you change your microbiome, but you're not entering the danger zone yet. And maybe you need a little bit more of a yogurt with some probiotics. It's not clear. Some of these probiotics, they don't colonize, they're just passenger. They're gonna come and flush out, so you have to take it all the time. But you want to avoid the stressor. So if the stressor is inflammation, you have a GI problem, and you could be put into remission, prolonged remission, your microbiome probably will recover because they're not under the stress. The same for, you know, as soon as the infection is gone and the probiotic or the antibiotic is removed, you will bounce back to some sort of a normalcy. It's just a prolonged stress on the microbiome that may be difficult, and it's not coming back unless you give something. But we don't know what to give you. If I give you the latest probiotics that Nestle is selling, it doesn't mean that you're going to restore your microbiome. You just put more of a different biome that is supposed to be good. So all these questions are extremely important. We don't have a precise answer to it. But intuitively, you will think, if I have a bad microbes, I need something to replenish it, and I will take these good bugs. Theory, it sounds great. In practice, we have no idea if it works. Because if I take a picture of your microbiome, here you look like that. In the disease state, oh, look at this. If I give you probiotics A, B, or C, now you're going to go back to this. No one has this knowledge. Yeah, no, absolutely. I mean, there's companies out there. Ubiome will offer you, you know, a little bit like, you know, a DNA footprint. They will get you your microbiome. So you will see map, and you just don't know what it means, right? It's a phylogenetic assembly of microbes, and they will say you're here, and the rest of the people are here. Oh my God, that's not good. That means nothing, right? But you know, you just have a snapshot of what you are. The most important is what happened when you have a disease state. How does it look like now? And is there anything that could be done about it? But this knowledge will need multiple time point collection, and no one's going to do that. You know, oh, I don't feel very good. Let's check my microbiome. Go to the doctor and let me see my microbiome now. Is it worse or than the picture I had when I was, you know, 16 and healthy? We don't know that.
Maybe in the future.
Maybe in the future. I mean, age is a confounding factor on changing the microbiome. As you aged, you lose diversity, you lose members, and we're not quite sure if that microbiome is defective as opposed to 16 years old. We know the extreme of age, 0 to 2, and you know, above 75. The microbiome is very different. In the early stage, very formative, building up, very very you know, dynamic assembly, and after that, it's pretty stable. It's pretty stable throughout your life until the end, where you start losing members, and that is associated with you know, aging problem, related problem that we see, and now we don't know. But that's fascinating, and that's why we need to keep investing effort on microbiome relationship with many disease. Cancer is certainly something that is of a great interest to many institutes.